Hi, and welcome back to this section, Get Real, Functional Programming, Iterators and Decorators in the Real World. In this section we're going to take a look at the importance of clarity, because good code is clearly written code. And we're also going to take a look at the meaning of the audience when you're coding, because who you write for, so your audience, determines how you should write your code. And finally we're going to take a look at a final example, which is going to be a modification of the interactive calculator that we've built before. But now we're going to modify this calculator such that it is implemented using a sensible mix of different programming styles. But let's start with this video, recognize the most suitable programming technique for the job. So here we're going to cover the importance of clarity, the importance of your audience, and we're going to take a look at different solutions for common scenarios. So we're going to consider two common scenarios and how you can solve these in different ways and what the advantages and the disadvantages of these solutions are. Now, and the main point is that writing code is just like writing in general, just like writing a novel or an academic article, in the sense that clarity and your audience are very important and should determine in part, in addition of course to your own personal preferences, but should determine in part how you should write your code. So, other things being equal, good code is clear code, right? If you cannot read and understand code, then it is not good code. What makes code clear? Well, it varies from situation to situation, but in general, short code is clearer than long code. Simply because a short piece of code is easier to keep in your working memory than a long piece of code, so it's easier to think about and to reason about. Short code is also simple, right? Good code is also simple. Clear code is simple. So in other words, if there is a simple solution to a problem that is for all intents and purposes equivalent to a complicated solution, you should always choose the simple solution. Good code, clear code, also resembles language. And in that sense, I think Python is very strong because the Python syntax very strongly resembles natural language. It resembles English, right? For example, the fact that you can use the word in to check whether an element is part of an iterator. That maps on very nicely to the English language, and that makes it also very easy to understand. So also when writing your own code, it is good to make it resemble natural language as much as possible. And good code, clear code is also modular. So if you divide your code, different functions of your code into functions or into classes or into modules, it will become easier to understand because every piece of your code will have a well-defined function and you don't really need to bother with the details of how that is implemented. So a good, modular, well-structured piece of code is generally clearer than a messy piece of spaghetti code where all functionality is kind of spread over the entire code base. And I think very importantly, don't write to impress, right? So don't write your code to show how fancy you are and all the advanced programming techniques that you know. Instead, write your code to be as clear as possible, and that way you will actually come across as being much more knowledgeable than when you try to write very complicated code. And an important thing is that you need to assume that your code is read by others. So very rarely do you write a piece of code that no one else reads ever again. Even if only your future you, right? So if you write a piece of code, and then no one else will read it, but after say a month or a few months you will read it again, you are essentially almost a different person, and you are then your audience, right? You are the audience that needs to be able to understand that code. And of course, in many cases, other people than just yourself will read that code too. And you need to adjust your code to the preferences and the skills of your audience. So if you know that your audience is a group of developers who are very well trained in functional programming, then it is fine to use functional programming techniques such as map, etc., and memoization, etc., right? But if your audience consists of developers that are not particularly skilled in functional programming, then it pays off to be a little bit cautious in using more advanced functional programming techniques, because otherwise you will simply lose your audience. So let's take a look at a few common scenarios and how you can solve those in different ways and what the advantages and different disadvantages are. So here we have a list. And this is a list of Adam Sandler movies released between 2012 and 2015. And the list, each movie is represented by a tuple. And the first element of the tuple is the title of the movie. And the second element of the tuple is the freshness rating of that movie on Rotten Tomatoes. So Paul Blart Mall Cop 2 was surprisingly not rated very highly. Hotel Transylvania did have quite a decent rating. Now, and say in this hypothetical scenario that what we want to do is two things. We want to take this list and transform it. And the transformation that we want to do is that we want to get only the titles and discard the freshness ratings. And at the same time, we also want to filter our list. And the filtering is based on the freshness rating, such that we only want to have movies that have a freshness rating of 0.2 or higher. Now let's consider a few ways in which we can do that. The traditional approach would be to use a for loop. Right, so that's what you see here. So what we do then is create an empty list of selected titles. We would loop through the Adam Sandler movies, get the title and the freshness. If the freshness rating is less than 0.2, we would continue, so we would ignore the movie. Otherwise, we would add the title to the selected titles. And then we would print out the selected titles and we would end up with That's My Boy and Hotel Transylvania, because those are the only two titles that have a freshness rating of 0.2 or higher. So that would be the traditional approach, and the advantage here is that everyone can read this, right? It's just a standard for loop, and even novice Python programmers will be able to follow this. So that's an advantage. It's an important advantage because it means that your audience will be able to understand what you're doing here. The disadvantage is that it takes quite a few lines to do something that is pretty simple. So in other words, it is unnecessarily long, and that makes it a little bit difficult to read. So let's move on to another approach, which I would call the Pythonic approach, using a list comprehension, which we've met in this volume. And what we're doing here is essentially looping through the Adam Sandler movies and extracting only the title. At the same time, we're using the if clause that you can use in the list comprehension to select only those elements, those titles, for which the freshness rating was 0.2 or higher. And then we store the result in selected titles and we print it out. And you see the code is equivalent. We still end up with two titles, That's My Boy and Hotel Transylvania. Now, in this particular situation, this is my preferred solution. Why? Well, because it is very easy to read, right? List comprehensions, even if you're not familiar with list comprehensions per se, they are still easy to read because they're almost natural English language. So even novice programmers might not be able to write a list comprehension, but they will be able to read a list comprehension. And also, it is only one line, essentially one line of code, so it is very short, and that makes it also clear. So I think, in my opinion, is a good balance between simplicity and conciseness. Then we have a functional programming approach, so using map and filter. So if you see functional programming languages that are purely functional, you will often see things like this. And just the fact that I have to walk you through this already illustrates that it's a little bit more complicated than necessary. Right? So we have our Adam Sandler movies, and we pass them to the filter function to filter out those movies for which the freshness rating is 0.2 or higher. So the first argument to filter is going to be a lambda function that returns true if the freshness rating, so element at position 1 of the movie, is 0.2 or higher, and false otherwise. And then we end up with a list of Adam Sandler movies with 0.2 freshness rating or higher. And what we then do is use a map to extract from these movies only the title. So the lambda here, what it does is it takes the movie, which is a tuple of a title and the freshness rating, and it returns only the title. So that's how we do the transformation. And then we print it out. We need to turn it into a list because a map returns a special kind of iterator that you cannot easily print out. But if you turn it into a list, you will see that it's essentially equivalent to the approaches above. Now, I think in this particular case, I don't have any problem with map and filter. They are beautiful functions that serve a beautiful purpose in some cases. But to solve this particular problem, I think this is not a good approach. It is very difficult to read. And even if you know how map and filter work, for me it's difficult to read. And most people don't know how map and filter work, or they don't really have a very clear picture of it, and they will be completely lost if they see this kind of code. In this particular case, I would say this list comprehension solution is the best approach because it is readable and it is short. If you are programming for hardcore functional programming aficionados, you could consider also this and filter approach. They will enjoy it maybe. It will be intuitive to some people, not to most people, but it will be intuitive to some. And this verbose for loop, I don't think has any particular advantage. It's mostly what someone would write if they don't know how a list comprehension would work, but I think the list comprehension solution here is in all ways superior. Okay, so that's one scenario. And I sort of walked you through my train of thought to explain why I think some approaches are better than others. Now let's consider another common scenario in which we have two functions that are stateful, in the sense that they sort of have a state. So what do I mean by that? Well, for example, the Fibonacci function is stateful because the return value, the next item from a Fibonacci series, depends on the two previous ones, right? So, for example, 1 is the first element from a Fibonacci series, followed by 1. Then we have a 2 because they add up, right? So the next element from a Fibonacci series is the sum of the last 2. And for a Fibonacci series, the next element is the sum of the previous 3. So they are stateful in the sense that they need to maintain this history of the series so far. Now, how can you solve that? So say that we want to, in alternation, get Fibonacci and Fibonacci numbers. The traditional approach would be to do that using functions. So we could do that, for example, as follows. We would define a Fibonacci series function. It would take the series so far as an argument. We've generated the Fibonacci series so far, and that we pass as an argument. We check whether the series is longer than, is at least the length 2, else it returns 1, right? Because the first 2 elements from a Fibonacci series are 1. Else it returns the sum of the last 2 elements. And for the Fibonacci series, something very similar happens. We pass the Fibonacci series so far. If the length of the series is 0, we return 0. That's how the series is defined. If the length is less than 3, we return 1. Otherwise, we return the sum of the last 3 elements. Now, if we then want to alternate through them, what we do is we define an empty Fibonacci series, an empty Fibonacci series. Then we have a loop here of length 10. And then we say, okay, we call the Fibonacci series. We get a new Fibonacci item, pass the Fibonacci series so far, right? And then we add the new Fibonacci number to the Fibonacci series. We also print it out. And we do the same thing for the Fibonacci series. Now, what is not very nice about this solution is this is kind of spaghetti code in the sense that the Fibonacci returns a Fibonacci thing. Then we have a series that we append it to. It's fed back into the Fibonacci, right? So the logic of the Fibonacci series is kind of spread out between this function and the for loop here. And the same is true for the Fibonacci series, right? The logic of the Fibonacci sort of spread out between this function and the for loop. So I don't think this is a particularly elegant solution. It works. You can see here below I've executed it, that it works, but it's just not very elegant and it's difficult to read. So here I think the Pythonic approach of using generator coroutines comes in very handy. So what you see here is what we've seen actually before in this volume. We have a Fibonacci coroutines generator, which yields a 1 first time, then suspends, then yields 1 again, and then ad infinitum it yields the Fibonacci series. So a coroutine, a generator, can be stateful because it doesn't end when it has returned a value, right? It simply suspends. In other words, the fact that we don't have to call this function from scratch means that we can simply, within this function, maintain the current state of the Fibonacci series. And that's quite nice. That's exactly what we want here. And for the Fibonacci series, it's the same thing, right? So we maintain inside this generator, we maintain the state of the Fibonacci series. We maintain the history of the numbers that we've had so far. And that allows us to very cleanly separate the Fibonacci and Fibonacci series from the for loop that calls them. So here we do, right? Here we can simply iterate through the Fibonacci and the Fibonacci series in parallel. We zip it with a range 10 to make sure that we don't enter an infinite loop, and then we can print them out. And you see functionally this is the same, results in the same kind of series as here. But the nice thing of this Pythonic approach using generated coroutines is that it allows you to create very modular code. It really, all the logic of the Fibonacci series is embodied in this generator. All the logic of the Fibonacci series is embodied in this generator. And the logic of the for loop, which is very simple, is embodied in the for loop. So that makes this code very easy to read and very easy to understand. So I think this would be a case, an example, scenario, in which using generated coroutines makes a lot of sense. It results in good, clear code.